Doing for the quiz on 12.3 and 12.4, and one of the major topics is Venn diagrams. So here is one. I've given you enough information to be able to figure out what number goes in every Venn, or every spot on the Venn. First thing I would start with is find the middle, because the middle is the only number you can absolutely trust, and put it right in there, because, but you're right. I'll get to that in a second. Of all these numbers, all the ones in the middle of the chart here, the very, very middle is the overlap one. That doesn't have to share with anybody. That 11 doesn't get divided up between like these two spots, for instance. It's only in the middle. So you can trust it and you put it right in. And somebody mentioned there's one other exception to that also you can trust right away. Yes? The neither. The neither was the one that you can trust without having to look at it further. Okay, do you have a question? We don't know how many people yet. But we can tell by looking at the given information. Doesn't say, but can you just add all these numbers up and that'll be how many people? No, because there's a lot of overlap in there. So how many people total were polled will eventually go up here, but we haven't got that yet. All right, so to get started on this, just one more quick piece of advice. When it says, for instance, horses and cats, that's right here, that does not mean you go slap a 13 right there. What are the two things that are horses and cats? These two. So we got to say 13 total. And if we can trust that 11, what do we know? That this must be 2, because that'll make it a total of 13. Get the idea? All right, keep on going just like that. I'll pause while you finish that. Okay, to keep going here, let's say we have 15 for cats and fish. That means between cats and fish, which is right here, we have a total of 15. That means this must be 4. And this one turns out to be 3 because of that one, horses and fish. And then the horses total was 21, so that means that the 11, the 3, and the 2 together add up to 14, 16. This must be a 5 to make a total of 21. And you just keep on going like that. What's this number for cats? 1. And what's the number for fish? What? Can't hear you over the noise. Thank you. And when you add them all up, has somebody already done that? Every single number added. Anybody verify that? 33 sounds correct. Okay. So now we can actually answer a question about it. There's a part A and a part B. Try them. So on that first one, given that they had a fish, that meant that all the fish numbers needed to be added together. And they added up to what? 21. And the probability they also had a cat. Now, the ones that were possible here are right in here. The ones that had a cat, it'd be really easy to just say 4, but that's not right. The ones that had a cat was the 11 and the 4, making 15. Raise your hand if you had 15 out of 21. Good. All right. Next one. Given that they had no cat. Well, it's kind of like the opposite of one of these normal givens where they just say circle the area you can do. No cats means don't use any of these. And that means you do use all of these, including that 4. Those are all possibles. So I add them all up. 5, 6, 7, 8, 9, 10, 11 plus 4 is 15. And then probability that they had a horse. Of the ones that are possible, the horse ones are the 5 and this 5 and this 3. And so that makes 8 out of 15. Raise your hand if you had that one right. Good. All right. I think you're solid on those then. Warranties are good problems because they happen in the real world all the time. When you buy a new phone or a new whatever, you got an option to get a warranty almost always. Why? Because companies make money. Let's see on this one whether or not they would make money on you. Remember, there's only 2 choices. What are they? Either works or it breaks. Now with expected value, remember it's P times A and then you add them all up. The probability is given in this problem. The amount's a little more tricky, but you multiply P times A and then you'll add them all up. Go ahead and finish that one. 0.05 wait, oh, that's for works. So I should put that as a 95 on works. Breaks 05. Okay, those are my probabilities. Now what? You would, if it works, you would lose $50. If it works, how come it costs you money if your TV works? Yeah, what, why? Yes. So you kind of wasted the $50 if it turns out it worked the whole time, right? Okay. Kyle, go from there. Notice that 50 shows up in both spots. You're right. Because you have to pay for the warranty no matter whether it works or whether it breaks. Final answer, let's just kind of, this answer and this answer end up being the same, right? What are they? 47 point what? Okay. Would I mark that right on the test? What's wrong with it? You're right. So they're the same except one's a negative, one's a positive. This one's negative and that one's positive. And there's one more thing that would annoy me on the test if we wrote that, yes? Yeah, let's add a 0. Okay, and now the fact that they are exactly the same means that it was a fair price. When you add them up, you get an expected value of 0. So by buying that warranty, you will get nothing. Doesn't mean it's a bad thing. Actually, it means that it was exactly fairly priced. The amount of times you'd use it compared to how much you get if you do use it it's a good deal. It's not really a great deal. It doesn't make you money, but it's exactly fair. All right. Now let's move on to the last kind. Expected value. This is a soccer situation. Let's say you are doing a penalty kick and you have a 80% chance of making it and a 20% chance of not making it. And this is pretty easy. I'm just going to multiply it out. 0.8 times 0.8, 0.64. That's 0.16, 0.16. What's 0.2 times 0.2? And don't say 0.4. 0.04. Okay. Now, what makes this an expected value is that the coach of this team decides to make it a little more interesting by saying, anybody this year who kicks a penalty kick and makes it, I'm going to give them $20. Just a nice crispy new 20. Okay, just to add a little excitement to it. So that adds a value. See, I got a probability. Now I've got an amount I can put. This situation of goal, what amount should I put? 40. And then what's this one? 20, because there's only one goal. And then there's 20 for that one. And what's this last one get? Nothing. All right, so I multiply it all out. When I add it all up, it comes up to, would somebody multiply that all out? Get me a number. So that ends up being $32. That's your expected value. Now, I'd like to change this name to expected average value or the average expected value. Because why? Because you'll never actually have the coach pay you $32, will you? So you really don't expect to get $32. But on average, if you had this situation happen a bunch of times, on average, you'd expect to get $32. It's just important that you don't think that we math teachers really think that you're going to get $32 from the coach. You won't. You'll either get 40, or you'll get 20, or you'll get nothing. But this is like a weighted average. Okay? So this 32 grand total would be the answer for what is the expected value for 2 kicks if you have these probabilities and this amount for each goal. It seems like you guys are understanding, following. Is there any last questions before we take the quiz? Yes, ma'am. Or an and. Good question. All right. So you have a Venn. I'm going to pause while I make one. If I asked you probability that out of these people that I pick somebody who plays golf and soccer, I would say just that one. 3 out of a total of 19 or 14. If I asked you for golf or soccer, then I would put this, and this together, and it would be 5, 6, 7, 8, 9, 10 out of 14. Do you get the difference? And is just in the middle, and or is all 3. The symbols for that, and is a union symbol, and or is an intersection